we all know that AI is going to take over the world, right? It's just a fact. Like, I literally talked to the director of Terminator and he told me that the actual movie was entirely a documentary with footage from the future, okay? And you might be asking,
Hey Carrara, what's the name of that director? And
I'd be like, well, I just don't want to tell you because, like, I don't feel like it. You know what I'm saying? Hello, everybody. I'm Carrara, and today we're going to be talking about artificial intelligence. So basically, if robots are going to take over the world, we might as well know how they work. And I know that machine learning is like a super complex topic, and it has like a ton of subsets, and it has a lot of calculus and advanced topics. But today I'm just going to break down the actual intuition behind it. Like right now, we kind of take for granted that AI could do a lot of things, right? They could learn to recognize their voices, like Alexa control us, it's fun, right? Or they could learn to beat us in video games. I just love it when AI gonna beat me in video games. It's my favorite kind of AI, okay? But really, if you think about it, all these AIs that we see around us are actually way harder to make than it might seem at first. Okay, let's just say that you are looking at a face. You could easily tell that I have a nose, I have a mouth, I have a face. Like, I mean, you could tell that, right? Unless you're a troll, in which case you probably can't. But, in the most part, you could tell what a human face looks like. But to a computer, that just looks like a jumble of numbers. Like, how are we supposed to tell a computer how to recognize a face if we can't even recognize a face from a bunch of numbers? Like, what are we supposed to do with this nonsense over here? So, how do they do it? Well, let's first think about what learning is, right? What is learning? Learning. What you do at school? No, you don't even do it at school. Like, what? What's the point of school? Honestly? Just kidding. We have love our teachers, okay? Teachers are amazing. But actually, learning is just using prior experience to make predictions about the future. I know this is like a super general definition of it, but it's true, right? Like for example, I know that my teachers always roast me for doodling, right? So I know that in the future, if I doodle again, my teachers are gonna demolish me. Another example is, I know from experience, from what I know that a test is, that if I sleep during a test, I'm probably not going to get as high of a score. Just probably. There's like a slight possibility that I'll get a higher score if I sleep, but like most of the time I'll get a lower score. So for most animals, it comes like really naturally just to be able to learn from experience. Something bad happens, you know how to prevent it in the future. You make a mistake, you learn how to correct it. You do something good, you get a reward for it, you keep doing that good thing. But how do you make a computer do that? That's the question. As I said before, computers, in order to learn stuff, have to analyze numbers after numbers after numbers. So, in order to find out how to teach machines to do it, let's see how we teach humans to do it. So when it comes to analyzing numbers, humans have pretty epic strategies, right? Let us say that we have a scatter plot of, let's say, hair length versus what? Test scores, how about that? So basically, as a human, you would look at this graph and you'd be like, oh, we could draw a line of best fit. That's crazy. So let's do that. Okay, that's not how you draw a line of best fit. Wait up. Hooray, we got a line, right? And we can see that as hair length increases, test scores also increase, which is why we have this mess over here in my face, you know? Look at all this hair. Just to get higher test scores, okay? No other reason. But basically, I just looked at this data and I fit a line to it, and now I can predict if my hair length is like to the right of all this data, then I can predict that I'll have a higher test score than this over here. If I was asked to predict if a guy has like a hair length of 50 centimeters, then what's his test score? All I would do is just draw a line over here, and I'd be like, oh, we use a line of best fit to determine that his test score is -5. Now, we don't only know how to do lines, right? We could do other functions too. Like, let us say that theoretically we're plotting, like, I don't know, how about test scores versus big brain power? That seems like a good idea. Then we could just draw our curve of best fit, and then make predictions based off of this curve over here. Like, we could tell from this graph that as our test scores increase, our big brain power decreases. Like, this is an obvious, like, well-known fact. I don't know why you guys are, like, doubting me like this. So, the thing is, AI learns in a very, very similar way. Its job is basically to find functions that match a set of data as well as it can so that it can predict things in the future. So let us say that our AI was trying to predict house prices from its square footage. We can't have any like of those nonsense big brainness. We can't make the AI do such menial things. AI has to be doing serious work. Only trolls like me get to do the troll stuff, okay? So basically AI just starts out with a random line. It just goes, well blammo, sure, that's our line for now. And then the AI keeps learning from new data. So maybe it'll get a data point over there, and then it'll draw a new best fit line. And then it'll get another data point, and then draw a best fit line for these two. And then our AI is just going to keep getting better and better best fit lines until eventually it gets to the line that could predict house prices extremely accurately. So basically the math behind this is kind of complicated. It uses derivatives and a lot of calculus, and it's not really that interesting to learn. But if you are interested in that, you can learn that in plenty of places. Alrighty, you guys ready for some name dropping? So to give you guys examples of some legit AI algorithms, there's something called linear regression, which is what we already saw. A line. It fits a line to the data. Then there's quadratic regression, which is like what you might expect, fitting a quadratic to the data. And then there's logistic regression, which is like fitting an S to the data, which is like kind of weird, but you know, But really what I've showed you only scratches the surface, because AI can do it in multiple dimensions. Like you could pass in more than just one thing into the AI network and get like a prediction based off that. Like an AI could consider many more factors than a human can. Now I'm not gonna bother drawing that because like I don't know how like 69 dimensions looks like, but it's cool. There's like so many cool things that you guys could do with AI. Can do like so much more than a human can because it can like visualize other dimensions and it could make predictions based off that. So while I'm name dropping at you guys, we might as well talk about neural networks. So we were talking about functions, right? Neural networks are basically just really fancy functions. And they're based on biological human brains. That personally is the coolest part about this whole thing to me, is that like you can apply biological concepts to make machine learning algorithms. It's actually crazy. So let's just explain the basics of how a neural network works. So it basically takes in some inputs, which could be more than one thing. You don't even need to take in one input like a lame like linear function. And then these input nodes, as they're called, then go into a hidden layer, which is your neurons. And as each input travels along one of these arrows, it's multiplied by something. And then these neurons apply another function to these things, and then pass it on to more neurons. And then the neural network keeps on going until it reaches the last layer, which then converts into a bunch of inputs, which don't necessarily have to be only one output, but in this case, we're just gonna have one output. So basically it takes in inputs, it gives outputs, and those outputs are really useful. And you can tell how it like kind of resembles a human brain, right? Because each neuron basically relays it to another neuron. And in your brain, the neurons are just making a bunch of pathways, and the pathway determines what your response is. So exactly like this, our neural networks have a bunch of pathways, and depending on what pathways they make, it has a different output. It's pretty cool. And that's the basics of machine learning. I think it's super cool how like people took something that's biological and put it into a computer and used it to solve problems and like use calculus and put everything. Okay, you guys get the idea. I think this is like super cool, and you guys should learn more about it. The place that I learned about this is the Coursera course, the Deep Learning Specialization by Andrew Ng, and it's really cool. That one goes into like a ton of depth on all the math, all the calculus, all the matrix multiplication, all the linear algebra, and just learning how all this stuff works is super educational. Let me know if you guys want more of these kind of videos that are not necessarily contest or like Olympiad related, but are just interesting to know. I have a couple other things in mind. More of these machine learning things are to come. And if you enjoyed the video, as always, leave a like and subscribe for more. Thank you guys so much for watching, and see you guys next time.